In this video we're continuing on problem 20. We have a right angle triangle of hypotenuse L, other internal angles M and O, and other two sides N and K. In the earlier one, 20.1, we found what K is. N is 12.61, the angle is 53.1, K is 9.74. We want to find L and M. In this video we're going to use our trig tools to try and find what L is. The first one we're going to go with is the sine function. So we have the sine of the angle O, we know what that is, that's 53.1 degrees, equals, the sine is the opposite over the hypotenuse. The side opposite the angle O is N, and that is 12.61 units, and the hypotenuse is L. We don't know what L is, we just put an L there. This looks promising. It is an equation with only one unknown, and we can solve that then to find L. But let's see, is there any other way of doing it? We could try cos. So the cos of the angle O, which is 53.1, equals the adjacent, which is side K, we know that from earlier on, is 9.47, divided by the hypotenuse, which is L. We don't know what L is, so we have here. This looks promising. It is an equation in one unknown, and we can solve that for L. Let's try our other one, which is the tan. The tan of the angle O, O is 53.1, equals the opposite, which is N. We know what N is, 12.61, divided by the adjacent, which is K, 9.47. This is of no use to us because we're looking for L, and L does not appear in this equation at all, so we can cross that one out. Another one we can look at is Pythagoras Theorem. Pythagoras Theorem tells us that the square of the hypotenuse is equal to the sum of the square of the other two sides. So L, we don't know what L is, we're trying to find L. So L squared is equal to the sum of the square of the other two sides. We know what K is. K is 9.47. So we square that, plus the other side. The other side, N, is 12.61. And we square that. This looks promising. It's an equation in one unknown, and we can solve that for that one unknown. The other tool at our disposal is that all the angles in a triangle must add up to 180 degrees. So we have the angle M. We don't know what M is, so we just write it in as the letter. Plus this angle, it's a right angled triangle. That's 90 degrees. Plus the angle O. And the angle O is 53.1 degrees. And we know this must equal 180 degrees because it's a triangle. This is of no use to us, even though it's an equation in one unknown. It's an equation in M, and we're trying to find what L is. So we cross this out as being no use to us at this stage. We have three now we can try. We know they will work. They're an equation in one unknown, and that unknown is L. Let's try the sine of 53.1. So we have the sine of 53.1 is equal to the opposite side, which is 12.61, divided by L. We want to isolate N, L. It appears here in the denominator of a fraction. We want to get rid of that. It's a divider here. This is an equation. If we multiply each side by L, we'll have an L on this side, and an L and a divider here will cancel each other out. So let's just go ahead and do that. So we get L multiplied by sine 53.1 equals 12.61. On this side we have L multiplied by sine 53.1. We don't want the sine 53.1. We want to get L on its own. If we divide each side of the equation by sine of 53.1, it'll cancel here and we'll end up on it here. So let's do that. So L equals 12.61 divided by the sine of 53.1. With L isolated on its own, all we have to do now is a little bit of calculator work here. So L equals to 12.61 divided by the sine of 53.1. We do a bit of calculator work and we find out the sine of 53.1 is 0.7997 to 4 decimal places. Bit more calculator work here to find what L is. L is equal, divide 0.7997 into 12.61 and we got 15.77. That's an answer we have for L. Now, that's using the sine. We also know we can use it using the cosine. We can find it with the cosine as well. So we have the cosine of 53.1 equals the adjacent, which is 9.47. 9.47 over the hypotenuse. We don't know what the hypotenuse is. In fact, we're actually looking for it. Now, we have L. We want to isolate it. It's as the denominator in the fraction here. That's a divider. We want to get this over to another side as a multiplier. If we multiply each side by L, we get L here multiplied by L divided by L. They'll cancel and we just get 9.74. So let's bring the L across. L multiplied by cos 53.1 equals 9.47. Now we want to get L on its own, not L multiplied by cos 53.1. This is a multiplier. We can, if we divide each side as an equation by cos 53.1, it'll cancel out here and we'll end up with a divider over here. So L equals 9.47 divided by the cosine of 53.1. With L isolated on a side, and all we need now is this side is just to do a bit of calculator work. So L equals 9.47. Use the calculator to find the cosine of 53.1, and that's 0.6004 to 4 decimal places. Bit of calculator work again. We'll find L is equal to 15.77 to 2 decimal places. This agrees with this, as it should do. Now we have 3 tools that we can use to find L. No one is better than the other. We're just doing it the 3 ways to show that it can be done. We're going to use Pythagoras, and Pythagoras tells us that the square of the hypotenuse is equal to the sum of the square of the other 2 sides. So copying that down from up above, we have L squared is equal to 9.47 squared plus 12.61 squared. Do the calculator work and square these up. So we have L squared is equal to 89.6809 plus 159.0121. Bit of calculator work. Sum those 2 together. L squared is equal to 248.693. We want to find L, but this is L squared. We can get rid of the squared by taking the square root of this. It's an equation, we have to take it from each side. So the square root of L squared equals the square root of 248.693. The square root of L squared is equal to L. So that's L is equal to the square root of 248.693 do a bit of calculator work, and we find out that L is equal to 15.77 units. This concurs, as it should do, with the way we found L by using the cosine and the sine. So we know what L is, equals 15.77. In the next video, we're going to use that to find out what the angle M is.